Think about this for a second. It's a problem so basic, we almost never think about it. You've got some kind of liquid right here, but you need it way over there. How in the world do you move it? We're talking about water, oil, fuel for a giant ship, anything. Well, for literally thousands of years, the answer has always been the same, the pump. It's such a simple, elegant, and honestly, a surprisingly powerful solution to this problem of just moving fluids around. And at its heart, the official definition is about as simple as it gets. A pump is just a device used to transfer fluids from one place to another. That's it. Sounds easy enough, right? Well, that super simple definition is hiding a whole world of some seriously cool engineering. So the big question is, how do these essential machines actually work? It turns out that pretty much every pump you will ever run into uses one of two basic strategies. You can either trap a little bit of fluid and then push it where it needs to go, or you can spin something really fast and just fling it. I like to call them the trappers versus the flingers. Let's break down what that means. Okay, so first up, let's meet the trappers. Now, their fancy engineering name is positive displacement pumps, and their whole strategy is built around precision and, control. The absolute best way to get this is to think about a syringe. You know how when you pull the plunger back, you draw in a very specific, fixed amount of liquid, and then when you push it, that exact same amount is forced out. That is the core idea behind every single positive displacement pump. And here is a classic example in the wild, the gear pump. This thing is a total workhorse. You see them all over ships, moving thick, gooey stuff like fuel oil and lubricating oil. All right, let's crack this thing open and see what's going on inside. The real magic happens right here with these two gears that mesh together just perfectly. You've got a drive gear that does all the work, and then an idler gear that just goes along for the ride. Okay, now watch this. As those gears start to turn and pull apart from each other, they create this little vacuum that sucks fluid right in. That fluid then gets trapped in the little pockets between the gear teeth and the casing. It gets carried all the way around the outside, and then squish! It gets squeezed out the other side as the gears mesh back together. See? It's a perfect trap and push system. And, this same idea, this trap and push philosophy, it works for other pumps too, like this piston pump. Instead of spinning, it uses this back and forth motion to pull in and then force out a fixed amount of liquid. The movement's different, but the core idea is exactly the same. All right, so what do you really need to remember about these trappers? Well, they give you a constant, steady flow. Doesn't matter what the pressure is. They're amazing for generating high pressures and for moving thick liquids. They can even pump air, which is a neat trick. It means they're self-priming. But, and I'm not kidding, this is the most important thing. You can never, ever start one with the discharge valve closed. The pressure builds up instantly, and trust me, something will break. All right, so we've got the trappers down. Now let's talk about the other team, the flingers. Their official name is rotodynamic pumps, and these guys are all about moving huge volumes with a ton of speed. And the king of the flinger category, the one you're going to see absolutely everywhere, is the centrifugal pump. These are all over ships, moving massive amounts of water for things like cooling systems, firefighting, and ballast. So how does this thing work? It's all about speed. Liquid comes in right at the center, in what they call the suction eye of this fast-spinning part called an impeller. The vanes on that impeller catch the liquid and then literally fling it to the outside at an incredible velocity. All that kinetic energy then gets converted into pressure as the fluid shoots out the discharge port. But, and this is a big but, this whole design has a major weakness. See, air is something like 800 times less dense than water. The impeller just spins around in it and can't get any grip to create that suction. That means a centrifugal pump just can't pump air. It has to be totally full of liquid before you can start it. And that super important step is called priming. Okay, so let's wrap up the flingers. Notice how they're almost the complete opposite of the trappers. Their flow actually changes depending on the pressure. They're built to move huge quantities of liquid, but at lower pressures. They really, really struggle with thick liquids. They absolutely must be primed before you use them. But, and here's that key difference again, they are perfectly safe to start with the discharge valve closed. All right, time for the main event. We've met both sides, now let's put them head-to-head in the final showdown so these differences really stick. Let's run through the scorecard. Flow. For a trapper, it's constant. For a flinger, it's all over the place. totally dependent on pressure. How about thick fluids? Well, trappers actually get more efficient because the thick stuff helps seal the parts. Flingers, they basically choke on it. Priming, a total must for flingers, but trappers don't need it. And that critical safety rule, remember this one? A closed discharge valve is a big no-no for a trapper, but it's totally safe for a flinger. It all comes down to the right tool for the right job. High pressure and thick stuff for trappers, high volume and thin liquids for flingers. So after all of this, why should you care? Well, because once you get these two simple ideas, trap and push versus spin and fling, you suddenly start to see the invisible systems that make our entire world work. And believe me, this isn't just some boring engineering lesson. That fuel pump in your car, that's Trapper. The massive pumps that keep our cities supplied with water and keep those giant ships stable, those are flingers. Everything is running on one of these two basic principles. They really are the hidden engines that keep our world moving. So from now on, when you see water gushing from a fire hydrant, or when you fill up your car with gas, maybe you'll think for a second about what's really happening just out of sight. You now know the secret of how that machine works. It kind of makes you wonder, right? Now that you know what to look for, what unseen machine are you going to spot next?